Hey everyone, welcome back to our stocks videos. Our focus today will be more on stock valuation. Specifically, we'll be calculating the value of the stock given the dividend payments. Then we'll consider some of these disadvantages of using the dividend pricing model. And then we'll try and use these pricing models to calculate the price of a per stock. So those are the three focuses for today. Now in regards to stock valuation, big picture, what we're really trying to understand is taking all the future cash flows that we expect from the stock and discounting it back to the present value. Okay. Now, in terms of what future cash flows we can expect, well, if the stocks pay out dividends, then that is considered a future cash flow. And also, when we actually sell the stock, that's also a future cash flow. So these are really the two major components of understanding the value of a stock. Once we understand those future values, we of course will use appropriate discount rate to figure out the present value. However, a little disclaimer about stock valuation is that there's no actual guarantee for this information. We're doing a lot of forecasting. Unlike bonds, there is actually no maturity date. We don't know when we're going to be selling the stock specifically. So with that being said, when we're valuing stocks, it's really more qualitative than quantitative sometimes, just as forecasting is, because the reality is we're really trying to predict the future. Now, in regards to how it stacks up to bonds, this really helps us emphasize that uncertainty. So going back to bonds, remember we knew the number of payments, we knew the maturity date, we knew the par value. There's a lot more knowledge in terms of what we could expect from a bond. But now looking at stocks, there's a lot more uncertainty, right? So we don't know when we're selling the stock. We don't even know the future value of that stock. We may not even be guaranteed cash flows, whether it's dividends. So there's a lot more unknown in regards to what valuation we can get in terms of actual income. So that's something to consider, particularly when we start talking more about risk. But let's take a look at stock valuation, and we're going to actually consider 4 different variations, okay? But in all cases, we're going to be valuing stocks that pay out dividends. And this is why we are using a dividend pricing model, okay? But not all companies pay out dividends the same way, and not all investors will hold on to that stock forever. And this is why we have these 4 variations. So let's look at the first one, which is the constant dividend model. Okay, so what that means is that in this case, the company is paying out dividends, but the dividends are constant. In other words, they're not growing. And in this case, we're going to be holding on to the stock forever. This is what we mean by infinite horizon. Second example or variation will be a constant dividend model where there's a finite horizon. So in this case, very similar to the first. The only difference is that now we're going to be selling the stock at a certain period. We're not holding it on forever. Now, the third variation is different in terms of the dividend growth. So in this case, the dividends actually are increasing. So we're actually going to receive an increase in dividends throughout the periods, but we're still going to hold on to the stock forever, i.e. infinite horizon. And finally, we have the constant growth dividend model. So we're now still dealing with growth in our dividend payments, but we are going to be selling the stock at a certain time. So it's limited in terms of our holdings. So let's look at some more examples so we really understand these 4 variations. First, going back to the constant dividend model with infinite horizon. Again, we assume that the firm is paying the same dividend forever in perpetuity. Okay, so what does that look like? Well, again, the dividends are all equal. Okay, so if we pay out $2, we're paying $2 out forever. With that said, we can use a perpetuity formula to figure out our price, which is similar to our present value. Okay, so in this case, R is the required rate of return, and the payment is the cash flow. So really, when you think about payment in regards to dividends, that is what we mean by payments. Okay, it's the same idea. It's that stock is paying out that constant dividend payment forever. So we can basically value our stock, the price of the stock, based off of the dividends it pays divided by the required rate of return. Well, let's look at an example. So in this case, we have a company that's paying out quarterly dividends of 50 cents and it's decided to pay the same amount forever. This is what I mean by constant payment. And in this case, Joe wants to earn an annual rate of return of 12%. So how much should he offer to buy the stock? Well, one thing to remember is to always make sure that our quarterly payments or dividends are agreeing with the rate of return. Now, right now in the example, we have quarterly dividend payments, but we have annual rate of return. So we have to make sure they're in agreement. So let's assume that we want to look at everything on a quarterly basis, which is fine. In that case, we have to change the annual rate of return into quarterly. So how do we do that? Well, we take our annual rate, we divide that by the amount of quarters, which is 4, and we get a quarterly rate of return of 3%. Okay, so now we actually have quarterly dividends, quarterly rate of return. That's wonderful. We can go ahead and apply our formula. So in this case, again, our quarterly dividends are 50 cents divided by our quarterly rate of return, which is 3%, which gives us a price of $16.67. So that is the value of the stock. That's how much we should offer to buy the stock if we expect to get a return of 12%. Wonderful. So let's move on to the second variation, which is now we still have the constant dividend, okay? But the difference now is that we're actually going to sell that stock at a certain time, okay? So we're not holding it on forever. Now, again, the dividends are constant, so that's not changing. And really, when we look at an example like this, go back to that two components of valuing a stock, okay? So first is figuring out the price or the value of the annuities, in other words, the constant dividends, and also the value of that single sum of that selling price that we're going to be selling in the future, okay? So again, remember, when we sell that stock off, that's our future value. That's going to be an income for us, and we also are going to be getting an annuity. We're going to be getting that dividend payment. So those two components help us figure out the value. Very similar, if you think about it, remember from those corporate bonds that we talked about, the payout coupons, same idea, okay? The only difference is that, with the bonds, again, it's a little more certain in terms of the par value, the maturity date. In this case, we have to sort of estimate the future selling price, okay? It's more of an estimation rather than a known par value like the bond is. But regardless, we can still go ahead. So in this case, here we have an example. We have the company, it's paying an annual dividend of $2. Again, it's not changing, it's constant. We're going to pay it out forever. The only difference now is that Joe, wants to earn an annual rate of 12%, but we're only going to sell it, we're only going to hold it for 5 years. So after 5 years, we're actually going to sell it. At the end of 5 years, we're going to sell it, and we're going to sell it for $20. So we're actually estimating the future value in this case. Okay, so now that we have that, how much should we purchase the stock for? Well, let's look. Again, think about our sort of annuity formula, and we can really pretty much use the same to apply this. So our annual dividend, right, the $2, that's our equal payment that we're going to be receiving is $2. That's not going to change. We know our selling price, which is the future value of $20. We know our annual rate of return. So remember, those two components is present value of the dividend stream of the 5 years, right? So what's the value of the income or the cash flow that we're getting from the dividends, plus what's the present value of the selling price? So after 5 years, we're going to be selling this stock. So what is the present value of that? So really, we're combining those two. Again, we can use a formula or an equation to figure this out, but we can also simply use our calculator or, of course, Excel and plug it into our formula. Okay, so really we're, again, just trying to figure out the present value of an asset given its annuity over 5 years, where we get annuity payment of $2 and we have a selling price of $20. So we can see here that our price that we should purchase is $18.56. All right, let's move on to the third variation. And really the key word here, the key change here is growth. Okay, so we now need to recognize that in these examples, the dividends are not going to be equal. We are going to get some sort of increased payments in our dividends. And because of that, we have to introduce the gentleman we saw at the beginning of our screen, which was Myron Gordon. Okay, so he's developed the Gordon model. And basically what he's figured out is a way to estimate the price of a stock based off of these constant growth dividends. Okay, very interesting stuff. And here you can see the equation. Not to worry, we'll sort of break it down. But what's important to recognize is we can see that the dividends now are actually growing. So this is the 1 plus G. G is really our constant growth rate. Okay, so if we're growing at 10%, that's going to be taken into consideration. And as you can see, the dividends are now different. They're not exactly the same. R is still going to be our required rate of return. So based off of this formula, we can actually come up with a price that helps us value this type of stock. Now we can sort of break it down a little more. We can pretend we do a little bit of math here. And a very more clean and simple formula here is really the price is equal to the future dividend divided by R minus G. That's really one way to look at it. Okay, so the idea is really two steps is figuring out the future dividend. And once we have the future dividend, we can go back and figure out the current price of this stock. Let's look at an example. So constant growth rate, infinite horizon. Okay, now this is one with a growth rate given. We'll also look at what happens when we don't have the growth rate in just a second. So in this case, we have a company and it's going to pay its shareholders $2 dividends. Okay. However, the dividends are going to grow at an annual rate of 8%. So if investors expect to earn an annual rate of 12% on the stock, how much would they offer to buy the stock? Interesting. Very interesting. So let's take a look at it and see if we can apply our Gordon model. Now, some good sort of reminders with Gordon model is that R and G must be in decimals. And also, R always has to be greater than G. Okay, and if you look at that mathematically, that's important because we can't have a negative number when we're dividing, or we can't have R equal to G because that would we'd be dividing by 0. But we'll look at that in just a moment. So again, how do we apply this model? Well, first we figure out our original dividend, which is $2. Okay, so that's dividend 0. We have the growth rate, which was 8%. So in this case, remember our dividend is going to grow, and we have an expected rate of return of 12%. So using that, we can figure out our future dividend, right, which is really the first step. So figure out the future dividend. In other words, what is going to be the value of the next dividend payment? So if we start at $2 and we have an 8% increase, well, that's what we're going to apply to figure out our new dividend or our future dividend. So we take the $2 and basically we're going to be multiplying 1.08, right? So adding 8% to $2 gives us the future dividend or the next dividend of 2.16. So once we have the future dividend, then we can go back and plug it in to the Gordon model, okay? Again, remember, the price is equal to the future dividend, which we just figured out, which is 2.16, divided by R minus G. And this is where you can start to see why R has to be greater than G. Okay, so the expected rate of return has to be greater than the growth rate. Otherwise, we get a negative value, and it does not make any sense. Can't have a negative price. But anyway, as you can see, now we've used the Gordon model, and we've assessed that based off of that condition, we'd be willing to pay $54. Okay, the price is $54. And notice how the price is actually higher than our previous examples, and that it makes sense because this stock is more valuable because our dividends are actually growing. So we're not just getting a flat $2, we're getting an increase in that. Okay, so this is an example of when we actually have the growth rate. Okay, sometimes though we might not actually have the growth rate, so we're still looking at the same variation. The only difference is in this case we have to actually estimate the growth rate. Okay, now how do we do that? Well, let's take a look. at our example, and that might help us figure that out. So here we're considering investing in this quick fix enterprise, and we're convinced that its last dividend payment, which was 1.25, will grow based off of the historical average. Okay, so we don't actually have a growth rate. We're just going to use some sort of historical average. We're projecting that the dividend payment is made based off of that growth rate. Okay, so what we're going to use is we're going to reference the last 10 years of the dividend history. And of course, we have a required rate of return of 14%. Okay, so again, we're making some estimations. This is a bit of that sort of, art form. So what we've decided to do is we're actually going to look at some dividend history. Okay, we're going to do some research. So here we are in 2014. Okay, but we don't know the growth rate. So we don't know what 2015 is. We're basically trying to figure out what is 2015 going to look like, but we don't have a growth rate. So we're going to use an estimation. Okay, we have a required rate of return is what we expect to receive. Okay, so in other words, in order to figure out this next dividend payment, we're going to use a compound growth rate. And the way that we do that is we use this formula here, which I think you've seen before. Okay, and I know it looks a little funky here, so let's make it more math looking. Okay, but really it's just our future value divided by our present value. And it's important to know the number of periods. Okay, so what does this number of periods represent? Well, it's the number of periods that the dividend has grown. So that's important. And don't be, sometimes people get that confused. They might think, oh, it's 10 years because we're looking at 10-year history, but it's actually the number of periods. So you can take the year and subtract 1, or you can literally count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 is the number of periods that the growth or the dividend has actually grown. The future value is actually the most recent value that we have. And we're actually, I know it's a little strange, but the present value is actually the least recent. Okay, so when we actually understand that, we take our future value divided by our present value, and we have n is our growth rate. Okay, or sorry, n is the number of periods. Okay, we're trying to figure out the growth rate, and we can figure out the growth rate again using our formula. So we've actually, based off of the history of our dividends, okay, based off of what we've seen in the, and this is factual, which is nice, but there's always drawbacks using history to predict the future. That's another story. But regardless, we figured out a growth rate of 10.72%. Wonderful. So what can we do with that? Well, now we can actually go back in the present time and figure out, or at least estimate, what the future dividend payment will be like in 2015. Okay, so our next upcoming dividend, so we'll take that original dividend, which is the 1.25, and the upcoming dividend is the 2015. So we have the 1.25, and we're going to basically add the growth rate that we figured out, and that's going to give us a dividend payment of 1.384. So that's basically what we're estimating, is that now we have a dividend payment of 1.384. And now that we have that future dividend payment, well, we can go ahead and use Gordon's model to figure out the price. So a future dividend is 1.38 divided by R minus G, and that gives us a price of $42.19. So that's an example, again, of the constant growth model with infinite horizon, but we did not have the growth rate. We figured that out using the compound growth rate formula. And finally, we have the constant growth dividend model with a finite horizon. Okay, so again, we still have growth with our dividend, but now we actually are not going to be holding it on forever. Okay, so the investor is going to hold it on for a limited number of years. Okay, that's important. That's the difference. So now this is a little bit different in terms of the formula. It's still derived from Gordon's model, but we have to add a couple of things. Okay, and I know don't get too fooled. Okay, don't be too freaked out. But so basically, in a nutshell, we're basically trying to first add on. In this case, we're actually selling the stock, so we have to figure that out, the price of the stock, and we're just discounting it back. But we also have to figure out for how long are we holding the stock for. And this is what sort of factors into here. Okay, so there's a bit of an adjustment in terms of the Gordon model. We have the 1 plus G here. So there's some variation. But one thing to keep in mind, and if you think about it logically, which is always helpful to do, is if we assume that whoever holds or whoever buys the stock after we held the stock, right? So if we sell it after year 5 or 6, and that other person expects the same rate of return, okay, then really, and so on forever, if that R stays the same, then we could actually use the Gordon model just like we used in the previous example. Okay, so there is an opportunity to do that. So let's look at our example here. So in this case, again, we have the Quick Fix company. It pays a dividend of 1.25. And we actually expect, and who knows, maybe these analysts expect the dividend growth of 10.72, well, based off of the history, right? So in this case, we do have the dividend, we have the growth rate, okay, and it's going to pay that out forever. But our plan is not to hold it forever. Our plan is to hold it just for 7 years. So that's important to know if we're going to be applying our new formula. And we have an expected rate of return of 14%. Now we're also going to make an assumption just for the sake of being able to apply the Gordon model. If we assume that the next person that purchases this stock is going to also expect a rate of 14%, then we could probably apply a Gordon model as well. So speaking of the ways we can apply, again, there's two methods. First is we'll actually use the official formula that we've seen. And then yes, if we make that assumption that the required rate of return is the same and the G doesn't change, it's a constant forever, we can still use Gordon's model. Okay, but let's start with the first method. Okay, so again, model 1 was that beautiful, cumbersome equation incorporating the fact that there's a finite period of time. Okay, and basically what we need to figure out first is figure out the price in year 7. Okay, so why is it important to know the price in year 7? Well, remember, this is when we're selling the stock. So that is going to be a future cash flow. So we want to know what the price is going to be worth in year 7. And how do we do that? Of course, we remember that we need to know the future dividend payment. So in other words, it will be the dividend payment in year 8 divided by R minus G. So how do we figure that out? Well, we can start with our original dividend payment. We know our growth rate that's given to us. We know our rate of return. So how to figure out the dividend payment in year 8? Well, we take the original plus times 1 plus G, okay, to the power of 8. So when we plug that all in, what we do is we actually get the projected dividend payment in year 8. So we basically know, or we estimate, if nothing changes, that we're going to get a dividend payment of about $2.25, 26 cents, give or take. So again, we have our future dividend payment. We can use that to figure out the selling price in year 7. And that's what we did. So this is our selling price in year 7. So that's a good start. Now we just have to discount it back. Okay. So really, once we figure this out, that really takes care of the number of periods. Okay, so now all we have to do is plug in our numbers into our formula here. Okay, so again, we have the original dividend times the growth rate, or 1 plus the growth rate. We have R minus G, right? So the rate of return never changes. Growth rate stays the same. And we've figured out basically the number of years. So we know we're holding it for 7 years. And that's why we have the 7 exponent here. And really everything else stays the same. Now notice how now we can actually plug in the price, because we know the price at year 7 is the $86.07. And all we're doing here is just discounting it back to the future, to the present. All right. So we've basically taken the value of our dividend payments plus the value of our selling price at present. And that leaves us with a present value or price of $42.19. Now, that was method 1. What do you think of method 1? Pretty interesting. Well, let's look at method 2. So again, if we make those assumptions about R and G basically not changing, we can still apply the Gordon model. And if we do that, we just take our first dividend and apply the Gordon model in regards to RNG not changing. Okay, so this is again assuming that the rate of return doesn't change and assuming that the constant growth rate stays, well, constant. We can simply use the Gordon model again. And we get, look at that, the same value. So either will work as long as the assumption is the rate of return stays the same. So those were examples of constant growth, okay? But, sometimes we have to deal with non-constant growth, okay? So, a little bit of a recap there. We talked about those four models, and really, what were the differences? Well, the difference was whether or not the dividend grew constantly or it didn't grow at all, right? And also whether or not we held the stock on forever or we sold it at a certain period, okay? So really, those were the differences. But the reality is, most companies, they don't have such consistency when it comes to paying out their dividends. There's some years where they might pay out more in dividend growth. There might be no dividend payments and so forth. So it can get a little complicated, but that's okay. We have these four variations for a reason, because we can basically use some sort of combination of these variations, right? As long as eventually there'll be some sort of constant growth, okay? We can finally use the Gordon model at the end. And really, before that, we can sort of look at each year as an individual basis. So let's look at what we mean by that. So here we have an example, okay, of a company, and they're paying out a dividend at the end of the year. Thereafter, the dividends are expected to grow at 25%. Okay, so they start at $1. We have a growth rate of 25% for 2 years, and then drop at 18% for 1 year. Okay. So again, we already see that the growth rates have changed. And finally, they're going to settle at the industry average growth rate of 10% indefinitely. Goodness gracious. So how many growth rates are here? That's right, 3 growth rates. Outrageous. Okay, so we really have to think about it in 3 different time periods. And that's important. So again, using a sort of a combination of what we've already learned, we can sort of apply different variations to different times in this investment. So we've given a 16% rate of return. Okay, so how much will we pay? So the idea is really figuring out the value of each period and then adding them all together. So first thing is we want to really, and it would be helpful to draw a timeline and something you can think about doing for sure. So in this case here, we have our dividends. And it's at the end of year 1, okay? So basically at the end of year 1, we start paying dividends, okay? And the question always is, okay, what's the growth rate? So it's the first growth rate is 25%. And another very important question is, how long is this period for? So the first period, or the number of periods, N1 in this case, is 2 periods, right? So at the end of year 1, we start paying dividends. Okay, so then for 2 years later, so in other words, year 1 to year 2, and then year 2 to year 3, we're paying this out. This is what we mean by number of periods for 2. Okay, then what happens? Well, then the next year, which looks like it's going to be year 3, we pay, or the dividend drops to 18%, and this is just for 1 year. So the number of periods is just for 1 year, and then basically it looks like after year 4, we have a GC, or a constant growth rate, of 10%. Okay, and this looks like it's going to be paid out indefinitely, or we can think of that as an infinite payment horizon. And in all cases, we're always looking at the same rate of return of 16%. So it's really important to visualize or break that down. And if you could visualize that without me drawing a timeline, then good for you. You've succeeded. You've evolved. So again, let's look at the steps here. Really what we want to do is figure out the annual dividend payments expected really in each year from 1, 2, 3, and 4. Okay. And once we do that, then we can discount them back to the present. But first, let's just do that. So How do we go ahead and do that? Well, remember we start end of year 1 with a $1. Then in year 2, we know that it's going to increase to 1.25 because of the growth rate, right, of the 25%. Then the year from 2 to 3, we still have that same growth rate. So in other words, for 2 periods, we have a growth rate of 25%. Okay, so the end of year 3, we have the 1.56. And then finally, there's that dip in year 3 to 4 where we have only an 18% growth rate. So we're going to take our dividend from year 3 and apply only the 18%, and we have a dividend of 1.48. So we've calculated the first, basically, 4 annual dividend payments. Okay, but what happens in the start of year 4? Well, remember, we're getting a constant growth rate, right? They mentioned that now they're going to sort of go to the industry average of 10% growth rate. Okay, so we can actually figure out the price of this dividend at the beginning of year 4, and that's important because we're going to be sort of holding it on for that period, right? So what we're going to do is we're going to use Gordon's model. We can take the 1.48 and we can apply that to our dividend model, or our Gordon model, pardon me, and we get the price of $33.73. Wonderful. So we've pretty much figured out the future cash flows. Now we just have to figure out how to push them back to the present, or discount them back to the present. So that's what we're going to be doing in step 3, is we're basically taking those future cash flows, discounting them back to the price of year 0. Okay, so first we're discounting the annual dividends, and then we're also discounting the price of at the end of year 4, because that's when we're selling the dividends. Okay, so that being said, once we do all that, then we can add them all up to get the current price. So here we go. Again, we have that $1, and all this we're dividing the 1.16, 1.16 to the 2, 1.16. All that is just showing the discounted rate or discounted value of these future values. Okay, so that's what we mean by discounting it back. And then finally, we have that price. We also have to discount that back. And really, we're using that expected rate of return of 16%. So when we do all that, then we basically get our current price. So our current price is $22.44. So here is an example where we're dealing with non-constant growth. We really have to look at it individually, and then we, in the way, put the sum together and figure out the present value of all the future cash flows. Now, you could use your financial calculator, a little bit of a functional advantage if you have the cash flow function, and the same idea as using the NPV, or net present value function. Okay, but don't worry too much about it. We'll learn more about how to use this. Well, we will learn more about it in Excel, but really I want you to sort of understand how to do it individually and putting it all together. Okay, but same idea. Cash flow function is very helpful when you have basically uneven cash flows, as you can see here, non-constant cash flows. Okay, so finally, we've discussed different variations of the pricing model. Now let's talk about what are some of the disadvantages of it. Okay, and maybe you might think about this. Okay, but we'll summarize them in just one moment. Now, some of the challenges is just really the amount of information that you need, okay? Because there's a lot of estimations going on. And the reality is actually sometimes we have companies that don't even pay dividends at all, okay? But as you just noticed, they're not always constant dividends. So if there's a lot of erratic patterns, it's very challenging to sort of keep track of, okay? And as we sort of mentioned, there's some companies that might not even pay dividends at certain periods, okay? There might be some declines in the trends. And again, just because there's a decline in a trend doesn't mean that trend is going to continue. So there's a lot of forecasting, a lot of estimations when we're using a dividend pricing model. Okay. And, the main concern is that not all stocks even pay out dividends. So we're looking or using a tool that is it's exclusive. It's not including all different stocks out there. So we want to use something that's a little more inclusive, and we'll come to that when the time comes. So those are some of the disadvantages with dividend model pricing. That being said, let's try and apply it to preferred stocks. So remember, what are preferred stocks? It's a form of financing when the owner receives a preset dividend based off of the par value of the preferred stock. So it's interesting, a preferred stock, it's somewhat like a stock and somewhat like a bond, okay? There's a bit of both involved, okay? But preferred stocks must receive its dividend prior to dividends sent to the common stockholders, okay? So that's what we mean by preferred stocks. So let's say a few things here, okay? What's also beneficial about preferred stock is basically is that you get a constant payment. Okay, so this is why it's similar to a bond in regard. It's more stable than a common stock. Okay, and also in regards to common stocks, it's also preferred in the sense that you get paid out first. Okay, so if you remember with common stock, there's more residual rights. Preferred have the priority of getting paid before the common stocks. However, sometimes dividends can be cumulative or non-cumulative, but the reality is most of the time is they are cumulative. And what that means by cumulative is that the investor is entitled to even miss dividends. So sometimes a company may miss a payment, but eventually they must pay that out to the preferred stockholder. Now, the reason why non-cumulative are not as common is because the reality is it's not a very attractive characteristic to have. So most companies don't issue out non-cumulative stocks. And if they did, it'd be very deeply discounted. Okay. Now, how do we actually calculate a preferred stock? Well, again, because it's a constant payment, and really the idea is that, there is no really end date or maturity date, we can actually use a perpetuity pricing model. So very similar to the idea that we're getting equal payments. We can use that to be able to price our stock. Okay, so think about the payment, again, our annual dividends, which is almost similar to thinking of it in regards to a bond where you have a coupon rate times par value. In this case, we have a dividend rate times a par value. Okay, and R is always really the expected annual rate return of the investor. Okay, so an example here is we have a company that's preferred stock pays an annual dividend of 8% on its par value of $60. So if we want to earn 10%, how much should we invest? Well, we can use our formula here. Price is our payment divided by R. And when we do that, we have our... Now, what's important is to figure out what is our actual dividend payment. And that's really based off of the par value. Okay, so our par value is, if our par value is $60, then we take 8% of $60, and we have our dividend payment of $4.80. And once we have that, we can simply divide that by our rate of return, and that gives us a price of $48. Well, you made it through. Thanks for watching. I know this was a long one, but hopefully we figured out how to value some stocks based off of some dividend pricing models. Thanks for watching, and happy financing.